first talk I'm going to give is kind of an introduction to Type 1L cements. It's a relatively new cement in the Texas market, or I guess the U.S. market. It's been around or allowed in specs for a couple years, and a couple of cement producers are starting to make Type 1L cement. So I just wanted to take this time to kind of introduce TxDOT to these cements. That's just the agenda. All right, so basically Type 1L cements, also known as Portland limestone cements, are pretty simple. They take a traditional Type 1-2 cement or Type 1 cement, and they intergrind a 5 to 15% limestone during the finish mill process. So relatively simple product to make for the cement producer, and it has a few benefits. All right, so just a brief history. PLCs have been used in Europe since the late 60s. You can see by the plot over there, this was I think 2004 data. About a third of the cements used in Europe are PLCs. So, and they allow up to about 35%. The norm is typically around 20% limestone content in these cements. And so they've had very good success with these cements in Europe. In 2004, ASTM C150, which is the primary cement specification, started to allow up to 5% limestone addition. So any cement you guys get right now in the field probably has about 3.5% limestone. They're kind of restricted to about 3.5, even though we do allow up to 5 because of other specification limits. You know, an LOI limit kind of restricts them from going to 5%. We're working on that through committee and trying to up that so the cement producers can get up to 5% addition. In 2008, the Canadian specs started to allow kind of the 1L method, 5 to 15% limestone addition. And in 2012, ASTM decided to start allowing a blended limestone cement in ASTM C595. And that, again, it allows up to 5 to 15% limestone addition. All right, so just some kind of basic properties we have. The first one is compressive strength. This is a mortar cube. You can see the blue is a 1L with 10% limestone, and the brown or goldish color is your typical Type 1-2 cement. Now these are the same clinker, just with the limestone addition, and you can see that there's not much difference in strength between the two cements. And the reason is 1Ls are generally ground a little finer, so you get that equivalent strength of your base Type 1-2 cement. Here's just some more data showing compressive strength of different limestone cements. And down here is that fineness I was talking about. So you have your typical Portland cement with the Blaine value, which is an indication of fineness at about 380. And then the 1L cements, you got a little finer to achieve that same compressive strength. Some permeability data, again, no major differences between the two cements, the blue being the standard cement and the yellow being the PLC. And that's with slag or fly ash additions, and so no major differences. When we look at bleed characteristics, again, the squares here are the PLCs. Since they are ground a little finer, you do have slightly less bleed, but nothing out of the ordinary if you were to have fly ashes in that same fineness category. So, just a little bit on fineness. When you intergrind that limestone in that mill, the limestone, since it's softer than clinker, it does grind a lot finer. And so if you look at the Blaine of just the limestone, you're up here in the thousands Blaine, okay? When you look at the clinker, you're down here. And so the blend of the two puts you on the red line here. So it may seem that you're getting finer, but really it's a false indication because the limestone is so much more finer than the clinker is being ground. So. All right, so what happens at that point? Well, you have cement grains, and then you have limestone particles. The limestone particles being finer, they will pack in between the cement grains, causing less bleed, giving you a little more strength characteristic because now you have less space for hydration products to grow, which is indicated here. You have a limestone particle. Limestone particles tend to act as nucleation sites, basically a place where hydration products like to grow. And so they start growing on the limestone particle and the cement grain. There's less distance for those hydration products to grow and then meet up in the middle. So you get this the strength benefit by having this space reduced because of those limestone particles being interdispersed between those cement grains. Now there is some evidence that the limestone particles do participate in hydration. They do react with the aluminate phases of cement, and they produce this thing called carboaluminate that may or may not have strength setting properties. That's kind of still debatable. But there is some evidence that we do stabilize etchingite and improve the pore structure of the matrix of the paste and increase strength. So that's one of the benefits that people are seeing when using Portland limestone cements. This is just a heat plot of a couple different Portland limestone cements and their parent cement. You can see this particular one, even because we reduced 10% clinker, we do have a reduction in heat. You have less material in there producing heat, so you do have some reduction. However, there's no shift. A shift going left and right would indicate a difference in setting, and we have no shift there, so it doesn't hurt setting properties. Here's a different limestone cement, and it's a parent cement, and we have very little reduction, even though we have a greater replacement level. The chemistry of this one is different, so not all limestone cements are going to behave the same way. So we really have to look at what is the chemistry of these cements and how they're going to behave in relationship to each other. All right, this is explaining why we set a limit of 15% limestone addition. So on this side of the chart, we have relative change of porosity and compressive strength. And this is limestone addition here. So if we add about 2% limestone, we have this fairly significant increase in strength and a decrease in porosity, which makes sense, right? Strength is related to porosity, so as porosity goes down, strength should go up. Well, that gives us a benefit of now adding more and more limestone until we basically get back to a zero relative change. And so that happens to be about 14-15% limestone addition. So that is where that spec limit basically comes from, is this data right here showing that we could put up to about 15% and not have a significant impact on strength. All right, one of the bigger things that people are finding is this strong synergy between type 1 cements and class C fly ash. And so this is with a limestone aggregate. This is an ordinary Portland cement, and this is a PLC. So just looking at the two, again, as I showed before, there's very little strength difference between the two cements. If you look at the 1-to-1 plot here, they're basically lining up right along that line. Now we go and we add 40% of the Class C fly ash. And now we see a 16% increase in strength at 28 days. And again, on the 1-to-1 plot, all our strengths are now above the 1-to-1, showing that when you add the when you add the fly ash, the Class C fly ash, to 1L cements, we're starting to see this synergy of increased strength right here. Now, one of the thoughts is that because Class C fly ashes are calcium aluminate based chemistry, again, the limestones will react with that aluminate phase in cement, so the same should go for reacting with that aluminate phase in fly ash. And so Class C fly ash has that aluminate component, and so you tend to see this strength increase. You don't see the same strength increase with Class F fly ash because it doesn't have as much as aluminate phase as the C ash. So this could be a significant benefit when we're looking at fly ash replacements and things like that. They're also finding that with gravels, we're seeing a substantially greater strength increase. Here is a 47% strength increase of that same PLC. So the same mixture, the only difference is now we have a gravel aggregate. And so it's uncertain what the mechanism is going on here, but again, it's still that aluminate phase reacting with the limestones and the cement. But the other component is the transition zone between the aggregate and the paste seems to get even more improved with river gravel as compared to limestone gravel. So we're seeing a significant increase in strength here as well. All right, so environmental benefits. As everyone knows, for every ton of clinker you produce about 1 ton of CO2. So if we're producing 15% less clinker because we could put 15% limestone in, then we should see a reduction of 15% CO2 production in cement plants. And here's just a plot of showing just that. Base cement, limestone cement, and you see the reduction of CO2. Plain and simple. Don't make 15% of it, you should get a 15% reduction. However, that's only the case if you actually reduce the production of clinker. Now, if you're making 1 million tons of clinker a year, and now you're adding limestone, but you're still making 1 million tons of clinker, you really haven't saved anything, right? You've extended your cement capacity. Now you make 1.15 million tons of clinker, but you're still making 1 million tons of clinker. So you have to be careful when people start talking about this environmental benefit of how are they trying to skew it one way or the other. So, however, that does extend our cement availability, and now we could probably rely less on foreign cements. I think Texas cements make about 14 million tons of cement. Texas consumes about 17 million tons, and so those other 3 million tons we're either getting from overseas markets or from out-of-state cement plants. So if we could produce 15% more cement in Texas, then we're relying that much less on these foreign cement producers, which who knows what environmental controls they have in their country. So, you kind of have to weigh out how you look at the environmental impacts when you're talking about these cements. All right, so this is just a map of a survey done about a year ago, I think 2014, of all the state DOTs who have accepted Type 1Ls in their state. This doesn't necessarily mean they're using them. Texas, we have accepted them, but we haven't really used the 1L cement on any projects. Cement producers are kind of gearing up. We have 2 approved 1L cements on our list right now. But again, it's not their primary product that they make. So they make a grind every so often, and they're slowly feeding into like kind of their residential markets, and then push it out to more of a textile market. So, but it is in our specifications. We do allow it. We just haven't used it yet. A lot of projects in Utah and Colorado have used 1Ls for a number of years as a different specification cement, but basically it's the same concept. And they've had no issues with any type of performance or anything like that. So they've had really good success with those particular cements. All right, textile specifications, again, as I mentioned, we do allow 1Ls. Our DMS for cement, 4600, covers ASTM-C 595 cements, and it is a allowable cement, and we do have 2 producers. One is Capital in San Antonio, and the other one is Wholesome in Midlothian. They both have Type 1L cements on the books. All right, this is where we're a little cautious with them. Item 421, which is our concrete specification. Table 8, this is the new specification. It dictates where you can use Type 1L cements, and for now we've limited to non-structural classes of concrete. So A, B, E, and the big one is Class P, right? Our paving concrete. And so we allow it in there, and we're kind of anxious to try it in a paving project. So if you guys are interested of trying to use one, please let me know, and we could work with the cement producers to try to get you some material. The other kind of big sticker for 1Ls is the sulfate resistant requirement. this is a very debatable topic, and there's a lot of research going on, even right now in Texas, looking into are type 1Ls cements susceptible to sulfate attack. And it's a completely different sulfate attack in terms of the classical external sulfate attack. It's a cooler weather formation of homicide in the concrete that we're really concerned with, and we don't really know if it happens. We could get it to happen in the lab, but no one's really seen it in the field. These things have been used in Canada for years and years and years. They've never seen a field incident of it. Utah, Colorado, very cold climate states. They really haven't seen an issue there either. So this could change depending on the current ongoing research, and we may not even have a concern with it in the future. So, but for now, it does. It is not allowed when you're having sulfate-resistant specifications for your concrete. As I mentioned, Texas is doing some research. We have Project 6858, and we're taking a step forward. We're looking at limestone cements with greater than 15%. Like I mentioned earlier, the Europeans have up to 35% limestone addition, and so we're just seeing the next step is we're going to start pushing the limit and seeing these greater limestone additions. So we want to be ahead of the game rather than behind it. And so we're looking at contents up to 30%. We have 2 cement producers on board with the research. They have ground us actual Portland limestone cements with up to 30% limestone. So we're just started the research. We're getting all the mixes done. And so University of Texas at Austin is doing this work, and that's part of the whole sulfate attack thing too. We're working with the University of Brunswick as well, and they have a sulfate exposure site that we're sending samples up there. So we're going to hopefully solve this sulfate attack issue. One of the things I mentioned, a lot of producers try to hit for an equivalent strength of a type 1 cement. We're not looking at that here. You start adding 20, 30% limestone addition, you're going to have to grind that cement so fine to try to get that strength equivalence, and that's just not practical. So we're going to treat this as not trying to be equivalent to anything. And so it's going to be its own animal, its own specifications, and whatever it does, that's what we're going to have to spec to. So pretty interesting project. A lot of work is going to be involved in this project, so we're pretty excited about it. That's all I have for type 1L cements. I have to do the next presentation as well, so I think we'll just save questions till the end so I can kind of just run through these presentations. So if you're dying to ask a question about type 1L cements, hang on to it.